Hello and welcome back to another day of Wormies and Leaf and compilers and OpenGL and STL and video games and all of that fun stuff. I hope you're excited. I figured out what the problem was from yesterday. Where I must say figured out is I randomly switched lines around until something worked. And you know that's often what coding is when you're dealing with libraries. So let's take a look at where we are and where am I? What file am I in? Right here is where we left off. Okay, last time we had problems with drawing, but now I actually have two different colored boxes being drawn. And you can't eat it yet. That's what we'll do today. And so we're going to keep working on that today. I can get rid of those things in the background. That was just debugging information. And so this is a game we're building, again, to explore algorithms. We're going to build the AI for this as well. And all the algorithms that come with this fun AI and also just playing with Leaf. So yesterday we had the issue that the boxes weren't working. So let's actually see what the problem was there. That's my Wormies directory, and that's in the GameRenderer. And zoom this in a bit. Should be able to see that. If you're interested in the code right now, it's over on, there's the link. And I keep that up to date. And so what the issue was this GL vertex attrib pointer here. I had these in a different order before, and it's unclear from the documentation whether GL vertex attrib pointer requires a bind beforehand. So this function here actually would bind it to the correct buffer and push. But this one takes the name location, so it's uncertain why this needs to be bound as well. But that fixed the issue. And I'm not sure if I have to bind this every time or it's part of this vertex array. Let's try it. Let's stick this way back up here. And this may or may not work if we change programs. It's hard for me to tell. And oh, we're gonna have to bind it. So let's just leave it. Let's just leave it alone. We might be able to put those back somewhere else, but let's just leave that. Now we want to make our guy eat the dot. Sorry, my eyes are really dry. Allergy season coming in, and that's what we have here. Again, if you have any questions to show about Leaf, the algorithms, game, whatever, STL, OpenGL, ask away. Some things I can answer, some things I can't, but I'll try my best. So we have the game render. The game render has nothing to do with the state, and we have this game class over here. And now when the game moves, we want to step it. We want to see if it's on the head position, and we're going to go to the eat me point. And I don't think I have an equals yet. This is going to be a big to-do. To-do. Implement equals on tuples. And we're going to have to deal with the lack of that. And so let's make a function anyways to find just define an equals function anyways, equals. And this will actually eventually be operator overloaded to do the right thing. Return a.x equals b.x and a.y equals b.y. And what we're going to do is when we move, if we're ever on the head position, equals head position, comma, eat me, then we're going to increase the length of it, the size plus equals, how much should it grow? I just make him grow by 2. That's enough for us to see the length. And we're going to have to move that. We're going to move the eat me position right now. Let's just quickly move it somewhere else. We're going to have to put a randomizer on here. So we're going to say eat me equals size.x minus eat me.x size.y minus eat me.y. This will be enough to move it. We'll just keep switching between two locations, but at least shows that the game will work. Let's go run that and see what we get. Unknown symbol add. Well, that's interesting. 31. Size. Oh, body length. Sorry, it's body length is what I'm trying to do here. Okay. So now if I go eat this thing, I should grow. So I got longer and it moved around. So we actually have the basic gameplay now. And we're going to keep getting longer, and it's always in the same location. And for the interest of the show, I'm going to speed up the which way the worm moves. I mean, this is a reasonable speed to start the game, but just because we're developing now, we can just increase the speed. And so you notice he's getting longer all the time. And let's speed him up first. This is in the main leaf that determines the speed of it. 150. It's at 250. Let's put it down to 150. And that should make it faster. And I make the window a bit bigger so we can see it normally a bit better for the stream. So now I'm moving a lot faster. And you can see that I'm growing a bit more. Okay, the next part is to render him dead if he dies. What should we do if he dies? And so now the worm's too long to actually eat these things. Okay, so we have the worm there now. That's very simple. If he does wrap around, before we worry about the randomness, let's take away this debugging nonsense first. This is over in the live lib. So in the common lib, this is GL buffer, which does this stuff. So you get rid of the print line here. Okay, and then what do we have to do now? We want to see if he ever dies. So how do we tell if he dies? It's when we move. And we're actually going to start in a position, we're going to say whether he's moving or not. We're actually going to do this. What was this for again? Oh, that's the requested directions. dir.x does not equal 0. Oh, yeah, equals 0, and dir.y equals 0. These are both 0. We haven't started yet. We're going to use that for the condition else that we do this, else we move. That's basically the starting condition. And after we move, what we're going to do is going to check for die, or check collision. Check collision seems like a reasonable thing to do. Define check collision. And we're going to make another function call. And these are going to make, I'm going to use this convention to mark these private this way because we don't support that yet in Leaf. Private functions is something we have to add. Check collision. I'm going to have a does collide function. And this will return a Boolean. We know it returns a Boolean, so we can type it right in here. And we're going to do the slow way for now, which is probably going to work fine. We're just going to look at all the items in the array. And we're just going to do it the plain way first. So for I in standard range 0 dot body dot get size. Now this has an iterator on it, and we should modify that after to show the language. I just want to make sure it works first this way. And we're basically going to say equals body.getI and head position. So if the head position is ever on the body, then we die. Then we return true. True. Otherwise, we return false. And so for check collision, it's going to be does collide. Does collide. Else return. We can do a quick return here saying just return otherwise. And otherwise, what do we do here? We're going to say we need something that says dead. Var dead Boolean. And it starts as false. And you can make it explicit too if you want. And maybe let's do it the other way. It's making him alive. We'll say he's alive. Let's say true. Alive. And in the step, we're going to say here, basically, if he's not alive, alive, else return. Don't do anything in stepping when he's not alive. Check collision does return, and now we say we collide equals false. So he's not alive anymore, and we're going to need some way to render this, so let's go off to the renderer. And we have a color here. We're going to say body color equals state.alive 0.5 0.5, 0.7, 0. These are hex values. Otherwise, let's make them just very red. 0.8, 0. That should work, and we'll make the box as the body color. And let's see what type of errors we get. Expecting symbol, GameRenderer line 72. And, oh yeah, I forgot, it's not that. This is the OR operator. Question colon in leaf, because colon always introduces a type. Parse expecting value, game 49. It'll be a while before I have full editor support. And I keep mixing languages, so we don't use ORs in this language, we use ANDs. Expecting node type, game 67. Equals, yeah. And we can do this inline too. If it equals true, then we return true. Alright, so we have an issue with the game render 74. So body color here, it's not clear. We had an inferred type here. It has to infer the type at this point. This side can unify to two tuples of rationals, but then it's going to over here make them integers. So we're going to force this one to the type we need right now, and that's a GL float 3. And there we go. And we'll make it long enough, and let's see if we can die now. There we go. We died, and we stopped moving. So we have the basic additions. Our worm dies. We don't have any other input. There's no way to reset this or anything. But I don't know how we want to reset this, but we have the basic game. And that should be good enough. I want to look at one thing first, and this is in this game code. This does collide. We have a better way to do this. We have iterators. Well, we have functional coding on this. Wormies, shared, standard library, X collections, vector. We have a function on the vector, and again, these are just classes we're writing, called for each. And it's not quite what we'd want. We want kind of a map and fold, and the for each would be enough, though. So let me show you how a for each would work. It's at least better than this. So you can basically do body dot for each. And if you look at the other one, it's going to take the body element. So it's going to be P. And now there's an issue as a function here. We don't have a short return, and that's the problem with the for each. We don't have a way to cancel out of it. And so, which is not tragic. Maybe we should write a find function instead. Find, and it can be an optional type. Yeah, let's write a find function instead. That'd be better what we want. We want to have a find, and we can make this part of the eventual interface. And find is going to return, it's going to take a function that takes the type and returns a Boolean. It's important. It's going to take a filter type, and it's going to find it of that type, and it's going to return an optional index, I think makes sense. An optional integer for the index saying where it found it. So it says where it found it. And this will be for I in standard range. Not reverse, we just need to go forward. 0, size. And here we'll say we're going to call the function f with the data at I. Then return I. So if we found it, return I. Otherwise, we return. This is weird. I'm not going to return anything. It's an optional integer, and the optional is by default going to be nothing, so we don't have to return here. Leave empty optional. So does collide now becomes a matter of we return has, and has says whether an optional is set. Body.find, and we're going to give it a function to call this back, and it's going to take the point. And we're going to make it call equals. Point to head position. Okay, I don't know. That looks a bit weird, but... Oh yeah, we're going to have to recompile the library as well. Recompile the standard library because it's not dis/build. Alright, there we go. Unknown symbol size. Where is that size? And that's in... probably over here. Oh, so something's gone wrong here. Well, that size should be fine. Where's the unknown symbol? So I got a defect here of where it doesn't say where the unknown symbol size is. Wonderful compiler error. I get these quite often, and that's a bit weird. There's no size over here. Let's just double check. Let's see if it does collide. If we make double collide return false, does the error go away? No, it's still unknown. So we have an issue there. It's not just in there. Vector, we're going to do a find, replace that, just leave it empty, and see if somehow that's the issue. Alright, so it's an issue in there. It doesn't have the known type size, which is a little bit disconcerting because the size is part of this class. Oh, this is the stupid font size again. I was wondering why I had all these spaces here. And so this is actually Kate again screwing me up. It's underscore size. There we go. Wonderful, wonderful Kate. Okay. Unknown symbol data, and it's probably the same thing. It's underscore data. Recompile the libraries. This is recompiling 4 of them. I could probably simplify that, but it's still fast enough that it doesn't matter. And now we eat. And we just want to see if we die. And we die. So the find actually works fine. So now we have a find function in the standard library for vector. We can find and we can do things like that. Now I'm wondering, what else should we do at this point? What do we want to do now? Well, let's do a quick random generator. We don't, because right now what happens, close the game because it doesn't restart. Again, if you have any questions, feel free to ask. Otherwise, I'll just keep doing this. It just keeps appearing in the same place. What we want to do is create a quick random number generator. I'm not going to create a full one now. I don't think I should call the C library. Maybe STL has a random generator. Let me check that. Maybe STL has random. And this is going to get... because this dot appears on top of the worm. Woo. Man, I haven't written this game in such a long time. I've written a bot for it. In the Evening Rush show, which is another one of my shows, we wrote a bot for this, and we're going to write this for here eventually, so we have a computer opponent to play against. And they're actually pretty hard to play against. They get pretty hard fairly quickly. And now let's see if we die. We die. Okay. I don't know what speed's going to be like. Leaf is not particularly fast now. These operations and stuff, there's a lot of allocations going on because it's like really, I've done no optimization passes whatsoever. I've kind of made sure that it's not going to be stupid, but it does really have significant issues in some areas. Alright, so how do we implement a simple random number generator? And I happen to know one, like there's a XOR one, simple XOR random number. Oh, we wanted to check STL first. Maybe STL has a standard random one. That would be actually ideal. Is there anything called random? Nope. Nope, 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 nope. Now, there is a C library function which is random as well. Maybe we should just use that one. Is it part of the C library standard library? manrand? We have a random number generator. This should be on all platforms, I think, so maybe we'll use this. We don't know what randmax is, unfortunately, so that's kind of an issue. And we're going to have to... that's the problem. We don't know what randmax is, and it's not something we can look up at runtime. That's kind of annoying. Randmax may not be the same on all platforms. Well, we could take their simple generator here. Okay. Maybe we should just take their simple generator and create a new random number instead of importing this one. Yeah, let's just do that. Let's take the standard random one. This is basically what it is. It's going to be the same sequence of dots every time for now, but we can seed it another time. Let's get rid of this one again. Minimize. And we'll just stick this in the game for now because it's really not much of a random dots leaf. Not really much of a library we'd care about to expose. This is obviously C. I'm going to have to code this here. I'm going to say variable rand seed or rand current. That's probably just rand seed, isn't it? Rand seed equals 1. Rand max equals, I don't know, that's a pretty crappy rand max. Let's just go with it for now. It's actually going to be totally sufficient. 32767 for the game. I'm going to have a function definition. Maybe we should have one very explicitly rand next float. Whoa, this is a terrible one, but let's just do it this way. And it's going to return a floating point value. And we'll have internal values called rand step. And what will rand step return? Rand step is going to do rand seed equals rand seed times this plus that. Okay. This will probably overflow, and then it's going to return. And these are going to be binary. It's going to be binary values, so we don't worry about overflow and stuff. It's going to return rand seed divided by 65,000 mod rand max, modulus rand max. There is no that operator, so we're going to have to do like this, mod this, comma rand max. Our mod's a bit slower than theirs because it's assigned correct. So what's the next floating point value? This is really, next floating point value will be return rand step. Is this meant to be 2 times rand seed? This is a literal rand max. Is this really meant to be 2 times rand max? I think it is. I don't know. We'll just leave it. It's a shitty algorithm anyways. Rand step. And they're going to make this, convert this to a float, lossy float, divided by rand max. And then we're going to do another one, rand integer. I'm going to say a low integer and a high integer. And the question is, that'll be an exclusive high, so I'm going to say x high. Just make sure it's exclusive. Do we even need the rand float? We probably don't even need the rand float, but it's safer. But we'll do it this way. Rand float. So we're going to take rand step. So var range equals x high minus low. And then we can just further return rand step, mod rand step, comma range plus low. And this returns a binary, so we're going to have to make this lossy here. Make this lossy convert back to an integer. And then, in the game, let's make a function called set next eat me. Set next eat me equals. I forgot what I called it, sorry. Rand integer 0, comma size dot x, rand integer 0, comma size dot y. Alright. Set next eat me. And we should exclude stuff here as well. Set next eat me, but we'll just do it this way for first. That should create a random location. And mismatch fundamental random leaf 10. Alright, and this makes sense here. Rand max, rand seed, rand max. Rand seed has to be a binary as well. We'll make it very clear it's binary. Binary numbers are what unsigned numbers are in C. I'm just clearly distinguishing the purpose of these things. Invalid binary op line 10. Divided might be one of those things we're not supporting on binaries. Okay, I gotta fix some typing here. To do giving unclear error message. There's a type conversion here error at this point, and tabs are all wrong. So we're gonna have to clarify that later. But this is probably meant to be a lossy binary. These are all meant to be binaries, and one of them has the wrong type, I think. And let's make this one all lossy binary. Without the correct error message, I can't easily tell me which part of the type is wrong. Well, let's make a temporary step then. Our Q equals rand seed divided by 65536. Q divided by rand max. Rand max is a literal, so it shouldn't be a problem. 13. So it's definitely here. What are the two types of these things now? It's supposed to be a binary. We can confirm it here by typing it there. And rand max, we could also make it a binary if we want instead and confirm that that works. You know what? I may have forgotten to implement modulo for binary types. That's possible. Let's find out. Lossy integer. Weird. I know what it is. That's because now we have to convert back to binary. So I think I know what my mistake is now. Oh, come on, 1835. That's down here we have the exact same problem. Yeah, this was unintended. I think modulo doesn't support binary, which is a problem. It's meant to. I'll do that after the show, though. Let's just make rand step return integer for now, then. That simplifies it. It's not so good, but we can just let it return integer. But then we're going to have negatives. We don't want that. Wonderful. And it might be above rand max as well, but no, this should never be... Yeah, okay. See how simple things in a language can go wrong. Obviously this should be much easier, but without this module supporting binary, I can't really make this easier. Binary, 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 force it to binary, I'm going to force it to mod, and so we're just going to force this to lossy integer as well. Oops, open something somewhere. Well, it looked like it appears in a random spot. Let's see if the next one appears in a random spot too. Alright, so there's some randomness. Alright, so we have randomness. Concern is taking so long to compile now, though. Something started making it take a long time to compile. But we have the basic Wormy game with randomness, and we can't tell if the distribution is good yet. But at least we have that, and now it's going to get harder as I play. I'm actually going to have to worry about it. It shouldn't be too hard, though. We can make the computer play this as well. Just want to know what we do next, whether we incorporate text or do something more. Oh, we just barely made it. So the exhilaration, huh? It's just, you know, just as exhilarating as Dark Souls, no? I'm just thinking now, I'm just going to play this while I think about what feature we implement next. I already saw some speed issues in the compilation. It wasn't as bad as before. And so what can we do with that? There's not much I can do with it in this show. We're just going to have to live with it. We can start splitting off libraries. There are a lot of things I can split off that would speed up the compilation. I can put all the GL stuff into a library. Let's see if that works. Oh, that was living dangerously. Because it's like the compile time almost doubled since yesterday, which is weird. Or for now, what we can put on the show is we can probably put a game over text. Let's do from the text for now. Let's put text on here. See if we can get the text thing integrated. I have a text demo somewhere, and it just involves one more library. I'm gonna die. There we go. Okay. So we have the basic game, get status, get add Wormies random. Put this up here. Adding a random eat me location and extending when eaten. So all these to-dos and stuff give me priorities to work on in the compiler to fix these things. Because when I see expressions like this, it's like, oh yeah, you know, there's something wrong here. We have to fix the type somehow. There's something definitely wrong in that expression. And I think that one's the... probably because, yeah, just because it doesn't have the right type. Modulo is not supported for binary, which it probably should be. Okay, so what do we have to do now? What can we do next? Do we want to put... what we can do is we can put some sort of button to restart. Shall we try the mouse interface? Or text? Let's put some text in. Let's put some text. I've been working on text in another one over here, and this will be a bit of an effort. So TTF lib Wormies and GL Text is the text demo. And you can see it's upside down, but it has something called hello in it. Whoops. Ah! Where am I? And this is our text window, and this is as far I got the demo, and this took a bit. There's another error I'm having working on Leaf, but I got it to work. We have the text. I need a different blending mode. So let's get the blending mode here working first. How do blending modes work in GL? Let's get this demo working first so that we know how a blending mode works. And this will be STL GL Text main. It's a much simpler one. Text coordinates 0, 0, 1, 1, and this should be actually upside down. What we'd rather push is we want to say... How do we switch it the other way around? Upside down I want it. 1, 1, 0, 0. That should be enough. Does that make it the right side up? Alright, so that puts it the right side up at least. Now let's check out the vertex fragment, the fragment shader. And we do have the proper aliasing there. We do have the proper color there. I mean, the proper alpha channel. STL Text. This is a fixed format color right now. What color is that? I'm gonna make something darker so we can see it. Something more contrasting. Let's make it A0FA. And then when we clear the thing, we're going to make it clear to a stronger color. That's a brighter color. We'll make it clear darker to a bit of a yellowish. Make it slightly green background. And now we need to have the blending mode. So we have the colors. We have different colors that we want. And this should show up. And this is very pixelated because that's the font size I chose. I think if I choose a bigger font size somewhere up here, like if I choose 64, it'll be less pixelated. There we go. And there's a lot of ways to do graphics on or text on OpenGL. I'm just using SDF TTF right now because it's very simple. If you were doing a game that had a lot of text in it, you would probably go for the sign distance field rendering, which I actually did on the Fuse project. I actually did fonts that way, and I have code sitting around, and we'll eventually get back to it. But for a game like Wormies, which is going to have like a score and a game over and very basic text, we can simply use the basic SDF stuff right now, and that'll be absolutely fine. So now we need the blending modes. And how do we set blending modes? GeoBlend. Blend equation. Oh yeah, I'm just going to look this one up, because I don't know what it is. OpenGL alpha blending. Somebody's probably said it before. And I'm just going to grab the two functions. Blending. Oh, they even have a wiki. That's good for that. Blend enable, GL enable I, blend I. What's the buffer of the main buffer? They're just going to give me a simple one saying alpha. Oh, I mean, they're going to make me read too much, so I'm going to have to find anyways. This one's how can it alpha transparency. Blend function. G enable blend, GL blend function, source alpha, 1 minus source alpha. That looks like simple enough. But what is possibly wrong? Alright, that's just a value, so that should be fine. So what do we have is we have GL enable. I don't think I have this function here yet. GL enable. I'm going to add it to our little library. I'm going to add it to the GL library here. libgl. I don't think I have it. GL enable. Now let's just throw it at the end. And I'm manually importing these for now because I don't have a way to quickly. I don't have a program that does it. I'll eventually make it so you have a library that actually imports it. GL enable multi-GL. I'm just going to test the chat again, make sure it's working. Just in case somebody wants to send a message. We've been having problems with that. I don't mind if people are quiet. I just want to make sure that, you know, if somebody wants to say something, they can say something. Because we do have problems quite often in the chat that people can't see anything. Cap GL enum. This is a raw no throw, and this raw no throw is also on my list of things to change. GL enable. And where do we call this? We're just going to do. Actually, this is probably part of the window. We're going to blend it on. Pong, thank you, LoveLikeSM Text. We confirmed that we work now. That's perfect. And GL's window. We just can enable it here. GL enable, and what do we want to enable? We want to enable GL blend. Now we probably don't have that thing enabled yet either. We need to create that constant as well. So let's go to user include GL. We use a core arb. GeoBlend blend. Where's our stuff up here? And again, this will be a lot simpler, this bit, when we actually have something like C2 FFI, and I'll generate this entirely. But I'm going to have to improve the speed here. One of the reasons I don't want to generate entirely is not just because we can't support everything yet, but because the GL files are absolutely massive, and this might start challenging Leaf's front end here, because if we're going to compile this every time, that can be quite a headache. It's not that fast yet. So we've enabled blend, but we haven't set the blending mode yet. So we haven't done that. So now we need to set the blending mode. GLBlend function, GLBlend func. GLBlend func is pretty simple. I like the easy ones. Import GLBlend func. GL has so much history, nothing can be simple, everything has to be enabled and disabled, and there's thousands of little functions, and you know, if you love GL and you find it doesn't have enough functions, I encourage you to go look at its successor called Vulkan, and which makes GL look easy. Defactor is a GL enum, and it has a raw no throw as well, so it has no GLBlend function. And we're also going to need, which blend function do we want? We want GL source alpha and GL1 minus source alpha. So we need 2 alpha. Let's just look for the other ones in the file. GL source alpha. And do we say 1 minus source alpha? And 1 minus source alpha. They're both right beside each other conveniently. Stick these up here somewhere. So many of these little variables. These don't cost that much to implement in Leaf. The literals don't survive. Literals are, they're not quite the same as defines in C, but similar. They look like variables, but it actually takes the literal value, so this remains as a rational until it's actually converted to a core type. And so let's set the blending mode, GLBlend func, GL source alpha, GL1 minus source alpha. Alright, what happens now? Woohoo! And wow, okay, we've got some so this shadow on the thing. This usually has to do with a pre-multiplication error. One of the things, something must be off in the fragment shader, and I hate doing this, but we are pre-multiplying it here. Okay, so if we are using pre-multiplication, maybe we're supposed to be doing add. I always get this wrong in GL. I always think about what's the default here. If I take off pre-multiplication, okay, so those are the 2 different modes. So we're working in non-pre-multiplied mode, and I'm happy with that for now. Let's use just non-pre-multiplied mode for now. And so we have the hello text here, and at least we can prove that this is working. And want to put this over into the Wormies game, and we're going to have to start doing some layout. And layout is like, I always say layout is my specialty, but full layout is a really hard problem to solve. You notice another problem here is that, let's fix this one right here. You see this little blue line here? This little blue line is from the end of the O over here. This is because we're doing wrapping mode, and we're going to have to switch this to clamping mode. And which one does that? That's inside the fragment shader. That's a sample, texture 2D. Sampler. Let's see which one does that. Texture 2D clamp. Because what happens if you don't do the clamping mode is right at the end there, it's the border between the right and the left of the function, so GL rightly shades between them and it interpolates the values. So because it's assuming a repeating texture, and we don't want a repeating texture. And this is the most useless reference here. Clamp to edge. I know what I don't know. I don't have a good GLSL reference. Right, this is the exact same problem he has there, so that's why he wants clamp as well. But where do we set clamping? Where do we set clamping? I forgot how to set clamping. Let's do texture 2D, GLSL. There's got to be a reference to this. Okay. So I've got the sampler 2D, and how do I clamp it now? Clamp, clamp. Is there something saying clamp in here? How do I clamp again? Texture 2D is deprecated. Oh well, maybe I should just stop using it. Okay, so what is the function? GLSL texture. Oh come on, there's gotta be a good reference for this here. Shading language. Is it in the same thing here? Am I actually in the same? Oh god, there's got to be so many things that will function. Texture. Let's go down to T. Texture. Okay, it does. Sampler. I guess I don't need to go texture 2D. Maybe, maybe not. Let's just see if I can get away without calling the textures 2D. It's supposed to be from the sampler. That should be good enough. And you can still see the little bit of blue there. Because we need to clamp it. Now I have to figure out how you clamp it. Good, I got clamped. Is it an attribute on the sampler instead? It is, isn't it? It's not part of the fetching, it's part of the sample itself. Texture clamping, so texture clamp, OpenGL. Clamping mode, there's a mode on it. Right here, GL textures. GL texture wrap. See, they don't have a search on their page. They're also missing a header, so maybe they have a magical search in the header. And where do we set this? I just need the name of the function that sets it. Bind texture wrapping. How do we set wrapping? Text parameter I. That's what I'm looking for. GL text parameter I. There we go. Text parameter I is what we want. Text parameter I. See, it's just a matter in GL of figuring out what function you want. It's like I know the function is there somewhere, or whether it's in, and This is the danger. I've done a lot of GL work, but the first thing you do with GL is you tend to hide it away. You tend to hide it behind a library, and then you quickly forget what you did. You have a pipeline that works, and I've actually written 3D pipelines, and I just forgotten how all this works. Parameter I. I hope I don't have this already. GL Text. I already have it there. I'm a dummy. So I've been using it already. I'd probably call it exactly in that code as well. Yeah, right here. Again, Kate's hiding the... Whoops. Kate's hiding the underscores. I want... Targets is also a GL Texture 2D. This is currently bound GL Texture 2D, and I want GL Texture... Texture wrap or something. Texture wrap. How much do I have to wrap? How many things do I have to mark as wrap? Wrap S and T, that's the coordinates on there. It's only two-dimensional, should be fine. Texture wrap. I'm going to have to go grab these variables as well. Wrap S, wrap T, and it's going to be GL repeat, but GL clamp, I guess. Is there a GL clamp? Go away. Go away. We don't want that. GL clamp. Clamp. Clamp to edge or clamp to border. What's the difference between clamp to edge and clamp to border? Oh, that's weird. It has a border color. Aha, no, I understand why. Wow, this is a minor detail. I think I understand. So clamp to edge, if it ever needs to clamp, the normal mode is going to say, well, if the edge color has a color, it's going to assume that's the color of the edge. And clamp to border, clamp to edge border means, well, here's a special border color. If you ever have to clamp, use this color instead. I don't think it'll make a difference for us. We're going to clamp either way. So we can do clamp to edge. GL clamp to edge. We're going to have to do this for T as well. Texture wrap S. We're going to have to look back up here in the thing. GL texture wrap S and texture wrap T. We might as well take repeat as well. And we'll find clamp afterwards. Just keep sticking random literals up here. And we're going to need repeat or clamp as well, clamp to edge. And I just took this one because it was nearby in the file. Clamp to edge. There you go. Clamp to border is nowhere nearby. I don't know who actually maintains these files. I assume they have like some actual file that generated from this somewhere. I hope somebody's not maintaining that by hand. And the constants are really scattered all over the place. It's like really weird. I don't know how they come up with them. I would hate to implement a driver for this because there doesn't appear to be any pattern. The constants are just like random. It's just really weird. Alright, so we have clamp to edge, and that should make the little blue mark go away. Right, so there's no blue mark over there. The blue mark doesn't come back either. Good, so we clamped it to the edge properly. There's no blue mark. We can actually do it in the game now. Now, the first thing we probably want to do in the game is we want to allocate a part in the board so it doesn't fill the whole board. So let's take that out of the way first. Or no, let's get the text in there first. This is going to be a little bit issue. We have STL Text here. This is the file. It opens a font, it closes a font. And we're going to have to put this as part of the library. Alright, so this is the file I want to move into the comment area. This is all working now. So let's close that. by common area, we really have these just split up. So GL Text, STL Text delete. I'm going to move this into the lib git move it because I think it's part of that. And go over there. And now we can use it in our own code as well. And how do we want to do that? I'm going to clean my glasses. I can't see. I put something on them. Okay, and we have STL Text. These are the basic text functions. I'm going to comment out this stuff first. I originally converted the surface format from STL because STL UTF-8 blended. I'm actually calling the wrong function here. Under UTF-8 blended. It says it's ARGB, not RGBA, but it appears to actually be RGBA, so I don't have to do the conversion. If we ever had to do that, we could, or we can just convert in that side. Let's keep making sure this works. Yeah. Now, this says it's UTF-8, so I want to see what happens. What if we stick a smiley in here? So let's stick a random emoji, or my favorite eggplant or something. No, I better take one that's very common. Yeah, my font probably doesn't have it. That's going to be an issue. It doesn't do any fallback, I think. Right? So if the font doesn't have it, the basic STL text does not do any fallback characters. So if I stick this in here, it's probably just going to give us an empty block. Yeah. And so, like I say, STL Text is a basic library to get some basic text into a game. And it's not a full rendering library. If you use like something like Pango, which you're going to have to use later, it actually does a fallback. Because if you don't know how fonts work, most fonts don't have the emoji. Usually you have one like big Unicode fallback font in the system. On Linux, it tends to be the Deja Vu libraries, or I think Liberto. And they're both trying to have, or Deja Vu is trying to have a complete Unicode font set. So it becomes the ultimate fallback. So regardless of what font you have, if you try to use a character that's not there, it falls back through a list of fonts and ultimately gets back to the one where it has it, or it does a little box. But this is something you actually have to do in a library. There's no standard support for this on Linux. There's no standard support for this, say, on iOS, on Android. If you want to do text rendering, you have to do this fallback on your own. And that's where library, I think, like libpango comes in. But this sets us off on a tangent that's way more than what we want to do. So we're just going to drop the... We're just going to not support emoji for now. We're going to support simple ASCII text, Western language. It should be okay. Alright, so now we have to find a way to incorporate this into the main game a little bit. So we want to show some text on the screen. And how can we wrap this up together? We want to have font. We want to have this text. Loading the font is easy enough. Or should we wrap it in another class to load the font? I don't know. I don't know. We only have to load it once, so let's load the font. This has to be part of the renderer. Alright. Let's just copy some basics for now. We're going to have a separate program for the text, which is a good place to start, because we have to actually have a different rendering approach. So let's go into the GameRenderer, the Wormies game, Wormies in the renderer. And in the constructor, we're actually going to load this stuff. It's getting a bit overloaded now. We're going to initialize that. So I'm just going to keep the exact same thing for now. And fail tag string STL font failed. Font load failed. Probably have that wrong. Okay, and then I want to do what is text tree? GL text texture. Text title is a GL text texture. This is a service, so it's shared. I don't have to worry about copying. So I'm going to do text title. I'm going to render this for us. We're going to say Wormies. And we're just going to check that we don't fail anything yet for that. Go back to the Wormies one. Tag string. I really had to fix this. It's string tag. Should be tag string. GL text texture. Where is this located? In lib. GL text texture. Oh, this is weird. Just not finding it now. Missing constructor. Oh yeah. So that's going to be optional for now. Right, see, it's taking longer to compile every time, and that was something we did very recently. It was very fast yesterday. And so now at least it loads, but we're going to have to do a second program. And the renderer should probably split into two parts, but let's just jam it together for now first to see if we can get the text on the screen. And then we'll worry about splitting it, or should we do it... Yeah, no, let's make a second one. Let's make a second one called Service Game UI Renderer. I really don't know. I really don't know. No. It's going to have its own program. So these are going to be very similar. It has its own program. And we'll just put all this stuff over here. Another class, default construct. Get rid of this. Okay, we're going to have to create these vertex shaders as well. And how do we want to do this one again? I think it has the same, no, it's... We're going to take the ones from the text one. Start with them. Basics vertex shader, it has... This is really just a basic. This is a really basic one that draws a texture block. One. Very inefficient, but it's going to work for us originally. This is in the Wormies. We're going to have text block.vert, and that should be fine. And we're going to take the other one as well. The one that's GL Text, which is a basic vert. No, that's the wrong one. Basic frag. And save this as Wormies textblock.frag. Okay, and that should be enough. And that'll draw a block on the screen for us. Good enough for now. We'll close those off. Close that off. We don't need this open anymore. Keep that around for a bit. Actually, we don't need that right now. We may need that again. Basic vert, close that off. GameRenderer. So we're going to have a few things like this. I need to copy this whole thing so I don't miss anything again. And there's a good chance that maybe some of... it's really hard to modify this. So program.attach vertex shader wormies.textblock. I think it's what it's called, Wormies textblock.vert. And these are attaching the shaders to this object, and then we're going to link it. And then what we say, we're going to just cap that out over here, Wormies textblock.vert. We have L vertex position 2D and L text coordinates. And these are both attributes. And I can change those names to be consistent with our naming style. Vertex position, okay. Vertex position, vertex position, vertex position, and text coord. text coord. Internally, it can do whatever it wants. I'm actually unsure of how to do the naming on when you have an in-out of the same name, if there's a special way to do it. Text coord, we don't have any uniforms, so we can get rid of those. And vertex position, and then we have text position. And what do we have for those? We have v position, we have gluint, var, text position is also a gluint. So we have both of those. I don't need to debug them. I'm hoping it just works. Then we create a new vertex array, because we're going to set the settings here. Now we're really going to test if we can switch back and forth between programs correctly. Text position, we're going to enable the vertex attributes on both of those. And now we have to look at the main of the other program. Wow, it's a lot of stuff to set up a simple drawing, and let's just make sure I don't have errors yet. Alright, it's just slow, but we don't have errors, so that's good. Service game UI renderer, and so the game renderer is going to have a game UI renderer of it, a UI renderer. I'll just say UI, game UI renderer. And that should still work. Alright, so what do we have now? We have from the other program, the text main. We have all this stuff here. We have these buffers, we're pushing this data, we have static, 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 static. These are all static buffers now. There's got to be, we'd probably have a way that we can start simplifying this, but let's just do it this way for now. And vertex data, we'll just stick it full screen again. We're just going to overload the whole thing. And we can copy it right down here. These have the same basic buffers. So these are the same basic GL buffers, vertex data, vertex text coord. What am I calling this? Vertex position, text coord, I'll just call it. This is also an element array buffer, and this index data is also a uint. Vertex data, and those are initialized. Vertex data push, and we're going to bind them to static draw. Index data we're going to bind to static draw. These are the same things. And the text coordinate we're going to bind as that. So we have all those text coordinates. They should all be fine. And we're going to have to do this binding as well. I think this is a GL thing. So vertex is going to be attribute pointer as v position 2 GL float times GL float on line size. That's correct. There's two of those. And the text coord is also the same thing. Text coord is going to be text position. Look at all this stuff that can go wrong, yeah? This is why you use libraries. If you're ever developing your own game, this is why you use a library. Unless you really just want to learn OpenGL, where this gets really extreme. Alright, so we do this and this, and then we also have to do the index one. How is the index one pushed? It's not, apparently. Apparently we don't configure the index. How does the other main say? Well, that's weird. We don't configure the index somehow. So that's going to be prone to error. Okay. Now, right at the end of this one, we're going to want to say UI.render and give it the state as well. And we'll do the same basic rendered function over here in the state. And And we do a program.use. That sets up our program.use. And we're going to bind in our vertex object. This sets up all of the vertex attributes we've set, hopefully. And now the rest we're going to have to do. We're going to bind a buffer and draw elements. We know we have to do that. But we have to bind a texture as well. And oh yeah, one of the things has a texture. One of these has an actual, not this one, the fragment. There is a uniform here called text. So we're going to have to grab that as well. Text. Text position is a uniform. Let's go back to the GameRenderer. And we have another one of those for... why the hell did I call that text position? Let's call it TC position. I don't know. I hate naming things. And I'm always constantly designing these short and long names. Text position glue int. The actual text position is I get a uniform location called text. Too much stuff called text. And in the main example, what we had is we bound that to active texture bind texture. And that was enough. The geo text tree, what do we call our thing now? We have a text title. Text title.buffer. With any luck, we're going to draw text on our screen. Requires L value. Uh-oh. What do we do here? G76. It's right, because this thing is optional. We'll just grab it for now. Text coord 63. This was vertex text coord. I don't know why. I screw up naming all the time. I should just go for the long names. Rather than trying to get clever short names, I should just give them all the same long name. Alright, so we don't have text drawn on the screen. We have no errors, as is very, very, very typical of GL. Now we have to figure out why. Why do we not have things on the screen? Let's duplicate this. This is the first obvious thing that maybe I don't understand how this works. Just maybe. It's a pretty significant maybe. No, that wasn't the problem, but I'm going to leave it there for now. We'll say, is this necessary? We don't need to re-push static stuff, but maybe... Now, what have we done wrong? We do render... We program use. Let's see if program use is actually working. If we take this away, the main screen should stop working. Good, the game stops working. That's correct. That's what we want. UI render state. Okay. GeoBind vertex array. Where's the GL enable? GL enable's right there, so that should be fine. Vertex data push, bind, and jut is static draw. Vertex pointer. Did I mention how annoying debugging GL is? So let's make a section function. We're going to make it called render game. And in main renderer, we should actually split off at some point, so it actually just goes through the layers of the game. Make this render game. Render game state. Because then we can just comment this one out and see if we get anything on the screen. No, we get nothing. So let's focus on this first. Let's focus on why we get nothing on the screen with this renderer. Did the texture load? Let's figure that one out first. We can look through the block, the fragment identifier, and just say vector 4, 1. This should make it all white if there's any blocks on the screen. I hate this. I hate GL's optimizations. Anybody want to turn it off? Because the moment you stop using something, it disappears, and then you can't use it anymore. And that's my code detecting that it's not there, so we can just do this 1, 1, r.b, 1. That should be just enough to make sure it can't get rid of it. Alright, so there is something there. Something way off in the corner for whatever reason. Let's figure out why it's over there first of all. GameRenderer, what do we set? We set oh, because we're doing triangles now. Our index thing has to be different. 0, 1, 2, 0, 2, 3. 0, 1, 2, 0, 2, 3. 0, 1, 2, 0, 2, 3. So those are our two triangles, because we switched from triangle strip to triangles. Alright, so that's stuffed up over there. I'm totally fine with that not being the location we want. At least it's there. Now we don't have the texture correctly. Let's do r dot... Let's just do this. Let's do r.rgb plus 0.5. Right, so there's nothing in our texture. Our texture's totally screwed. But we're drawing it in the right location. Or we're at least drawing it. So we're missing the texture. And... although... wait. That might not be true, because we have the right color. Right, like where did that blue color come from? That's the texture color we're drawing in. Right, so let's figure out where the issue is. Let's make sure we're getting the correct formats. Let's go, okay, what's the problem here? Wow. Oh no! I can't believe I hit this limitation. I have in my code for debugging purposes in the compiler, I don't allow a template, I don't allow a parametric function to be instantiated more than 10 times, and that's the limit I'm hitting here. But obviously it's a silly limit, but it's... alright, but it's enough to cause a problem. Format, 32, that looks fine. Bits per pixel, let's check the size of it. And it's created the texture, so it's actually created the texture, so it should be fine. It's created the actual texture. It's generated, it's probably bounded. I don't think there's any difference here. We've generated all of this. Now, what's wrong with the renderer? Let's split this window and take a look at the original program over here, GL Text main. And shrink the size just a bit again so I can see more than one. We loaded the font and we've rendered the font. We know we have that so far. That's what we just checked. We have the font. And we create a vertex shader. We do a program. We do attach vertex shader, attach. V position. We get the vertex, we get the text chord, we get text. If any of these would fail, our code actually fails, as we saw before. Now, we're not using a VAO in that other program, but that shouldn't be a problem. When we enable these vertex attributes, that should be okay. We push, 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 and we know this vertex data here is, well, actually, to be honest, this looks wrong. It's in the wrong location on the screen. That's weird. Let's double check that first. So something might be wrong. Right, we're actually on the wrong position in the screen. Because these are normalized coordinates. So already we have the vertices wrong. And I say that because -5 to 5, this should be directly centered, and it's off to the side of the screen, so we're doing something wrong there. And when we were using triangle buffers before, a triangle strip, let's just go back to using the triangle strip for a second. And this was actually triangle fan, triangle fan. And let's check this stuff here. Triangle fan, that's the number of elements, is 4. And who does the swapping? Not us, the main program does it. Starting at the bottom, texture, textured buffer, title, program set uniform, texture position 0, and that lines up with a 0 here. Bind buffer, element area buffer, index data. And we just bind the buffers here. We don't have to upload it. But that upload should be safe as well. Enable vertex attrib. Now I don't think this actually has to be done a second time, but let's just try it. V position, position. And aha! This is a problem here. Text position is supposed to be TC position. So it's centered now. It's centered now. I'm not sure which bit changed that. We're going to go through and play with this afterwards. Vertex text chords. And if the indexing was wrong, we wouldn't draw anything. So now we must have a texture being the issue. Bind texture. Or is it simply too bright to see it now? Let's go back and put the other thing here. Come on, Kate, try to remember the size here. Vec4. Actually, we just say R. We're not doing any multiplication. Aha! We have text! Perfect. I'm using a font with the little leaves on it in the name of the language just because, hey, why not? So we have text. That's great. We don't need to do that. So we can start clearing some of this stuff off and figuring out what's actually necessary. How much of this is necessary? Because we do it up here. I thought we did it up there. Yeah, right there. And this is TC position. Alright, so that's not necessary, which is good. Get rid of that whole chunk there. Enable vertex attrib array. We already did that. Can we get rid of this now? No, we can't. Now, this actually kind of bothers me. I don't understand this bit. Why, if I have this vertex, this VAO, why do I have to re-enable these attribute arrays every single time I use it? I don't understand that at all. Because we bind it up here and reset it here. It's like this stuff does nothing. Oh, because of this TC. This is supposed to be TC position. Maybe that's it. Maybe that's the problem. Maybe it is working correctly. Alright, so that is working correctly. Before I get too excited, let's re-enable the main game to see that it keeps working. Alright, so we actually have layering. We actually have an actual game here. We can play it behind the title. Hey, why not? Let's play it behind the title right now. It's actually kind of fun to play behind a title. Woohoo! Since it's simple enough, we can do it. Alright, so we have text. It's kind of ugly, but that's okay. Now, the one thing we're going to hit a problem with right away is because of how we're doing the text textures, we're creating an independent text for each text we render, and we don't have an atlas or anything. What that means is that for any bit of text we want to write in the screen, we have to issue another draw call. Is that expensive? Yeah, probably not. We're going to draw like 3 or 4 text objects on the screen. Who cares? But if you had to do lots of text in like a UI program would, we don't have one, like an app program, you're going to want to have that atlas. But even with the atlas, when we did it at Fuse, the guy who did it, there's still a lot of work. You still have multiple atlases, and you still have to have multiple draw calls, basically one for each script. So every script had its own language in it, and that means the emojis were a different one. And that's also because they had colors in it. And we'll eventually get there, but that's not my priority now. We have the basic game, and that's actually as much as I want. Oops, and I died. Okay. So we have the basic walking around of the games, and we might just keep this around for the screen demo of how the game works. And how do we do this now? What else can we clean up? Let's see if we can clean up anything else first of all. Split view, close inactive view. Alright, so in theory, we don't have to call that thing multiple times. These bind things can be done at a different time. I guess that's the idea. Do I care that much? I do, because up here we did it. It's really not a problem to just push this here, vertex data, bind and push. It's inefficient, but it doesn't hurt us. We have to push it down there again anyways, but we don't have to change the format. Let's see if that still works. Whoa, what did I change? Bind and push GL dynamic draw, yeah. GL dynamic draw. Gotta spell it right. Right, so it's still working. So I'm just confirming GL that these VAO, these are properties of the VAO. So by using the VAO, we should be able to re-enable them. And I don't know how much we actually have to do there. We can get rid of this. We're going to have to resubmit them here again. That's fine. Program set uniform. I don't know how often we have to set. Are uniforms specific to a program? I think they are. Let's find out as well. We're just trying to simplify as much as we can. When we first create the program, let's set the uniform right there and see if it works. Oh, we don't have a state yet at that point, so we can't. Oh, well. That gets rid of that idea. We should probably give the renderer a chance to initialize in the state. So we initialize bind data, we push the boxes, eat me, and we bind and push index. Could probably do this all for here. It shouldn't be static draw, we're just being inefficient. Let's do dynamic draw as well. even though it's basically static. We're using the vertex object, we set the uniforms, we draw it, we bind it, and everything should be happy, and we still should have a game. Good, we still have a game right here. Right, so now I want to put the score somewhere. That was the whole purpose of this exercise. I'm going to leave the wormies in the middle for now, because they're fun. It's fun! It'll make the post on Twitter look better with that in the middle. And this, again, this is all dynamically sized, so you can make it really small if you want. This is what? This is about the resolution of the original Nintendo games? Can't believe we played games at this resolution. So we need to put a score on somewhere. I'm going to save the file first. I'm going to see that we die first again. Let's make sure we die. There we go. We die and the game stops. Alright, so what do we have for get status? Git add wormies text block.frag wormies text block.vert. I update the README file in case somebody wants to run this thing. It has to have -- library STL2TTF as well. Git commit adding title text. Alright, so we can push that up. Hope you guys are enjoying the show. I mean, probably not a lot of questions, but feel free to ask. The feedback helps me know what we're doing. Well, you can send it on Twitter as well. And so now we have these two textures here. And now we're going to have something called last score. Last score is an integer equals 0. Now, I don't even think the game had a score in it yet. Did it? No, we didn't. What the hell is the plus thing? Var scores integer starts as 0, but that's the default anyway, so we're going to have to set that. Score plus equals 1. It's going to increment 1 4 for each time we did dots, and GameRenderer is going to have last score. Text score equals GL text texture from text font, comma 0. Now, this is going to be a real challenge for us. I don't know if I have a standard. We have something that formats numbers somewhere, where it's going to be a little bit of a check to find it. And let's just draw this first. Let's change this to use sizing, though. Instead of an explicit vertex and stuff, we're going to use the exact same static draw positions, and we're going to give these things a size. So we're just going to put -1 and... Actually, this makes no difference. Vertex data is... Lovely, thanks, thanks, okay. Just confirming that somebody's alive watching. That's great. I'm okay with people chill. I mean, I'm just going it. I get a lot done. I get a lot done when people don't chat. See, because the moment you chat, I get sidetracked and I stop working. And, you know, so maybe it's better if people don't chat. Okay, so we're doing well. So I'm going to change this so that, because I want to reuse the same program. And we're going to give it a size. So we're going to go into that program, the vert thing, and we're going to give it a size. We're going to give it a uniform. And we might as well just give it a vec4 of size and position. Right? And we're going to call it placement. And so placement really is, it's just basically times placement dot x, y. That's the size, because the first bit is the position plus placement. No, this has to be z. This has to be z plus placement dot x. Do these have numerical indexes as well? We'll find out. I don't know. They might have placement times placement dot w plus placement dot y. So this lets us control the size from the program, but we still have to have fixed vertex coordinates. But we can really make them 0, 1, 0, 0 now. 1, 0, 1, 1, and 0, 1. And these are exactly the same as the text coordinates, or they probably should have been. You know, because the text coordinates are inverted, so that's fine. So we need to have an actual placement here as well. We need a placement position. I'll use the full name to make sure we're not cutting any corners here. Placement position. Placement position equals program. Get uniform location. Placement. And we're going to have to set this each time. Program.set uniform placement position. I don't know if I have this one overridden yet. This is a vec4. And let's check it out. Let's check out what I have in program. There's going to be an issue for overloading because there's going to be multiple ones that overload the same way. That's right, I have this get4. Set uniform, set uniform. And so now I'm going to have multiple floats. That's fine. This will work fine. V2, GL float. V3 GL float. Uniform 4F. We might not have 4F yet. Let's just check the uniform 1I. Uniform 2F. Let's just do 3F and 4F at the same time. Again, this is just the way GL was specified. GL has a different function for virtually everything. They opted for a C protocol over as another protocol. I don't know the history behind that. A lot of things would have chosen some other kind of protocol, but I guess the C protocol makes a lot of sense because it compiles well on the system and takes advantage of all the things you might have there. This is a V4. This is a 4F and this is a 3F. Make sure we bind to the right programs. Okay, back to program. We can do a set uniform. And this will be a set uniform. Where do we want to put this thing? We want to put this in the middle. So this is really going to be 0.5, 0.5, and the size 0.5, 0.5. This may look really weird, but that's what we wanted. Text score, where is that? 39. Text score we have to have here somewhere. Optional GL text texture. And this is actually kind of an error here that this needs to be optional to do. Shouldn't it need to be optional? Initialized in default. Okay, this is really weird. This is a really hard one to decide because it's initialized in default. But what if you use it before it's initialized and they don't have a default? Yeah. So Wormies is somewhere else now, which is not the desired approach. What did we do wrong there? Whoops. So we put Wormies off in the wrong location. Or did we? No, we didn't, because this is exactly what we requested. We actually want to put Wormies at -0.5, -0.5, and it has a size of 1. That's what we wanted. Yeah, that's where it was before. Now these are, again, normalized device coordinates run from -1 to 1 in both directions, and I'm not thinking too much right now about the actual inversion, whether I have a consistent layout here. I think I'm from bottom up, I don't know. But what this lets us do is we have this other one. We can redo this whole chunk here, and this is rather inefficient, but again, I don't care. Our GPUs are so fast in the system that it just doesn't make a difference. We're super speedy. Text position 0, and we want to put it in position 0, 0. Ideally, it would have a size related to the element, but let's just make it 0.2 and 0.1 in size, and draw it again. And we have something drawn in the middle here. And again, I wanted it -1, 1. Where'd it go? Uh-oh. Get my positioning right. That's a 0 there, I think. -1, -1. If I want it in the top left corner, let's put it in the top right corner instead. This gets a bit weird. The top right corner is going to be 0.8 and 0.9. And what we want to do is we want to say state.score does not equal last score. We're going to have to update the graphic. Updating graphics for text becomes really an issue. But we can do this anyways. We don't care. We're going to do this anyways. Going to update the text score, but we have to have a new text, and I've forgotten the name of the standard library thing that actually does this. Leaf, Wormies, share, standard library, standard float to ASCII. I have a float to ASCII. Do I just have a simpler to ASCII one? Print big integer to ASCII. Where is integer to ASCII? Why don't export it yet? Fine, let's do it. Export. Export definition of integer to ASCII. That should be good. And recompile the libraries. Standard integer to ASCII then. Integer to ASCII state.score. Last score equals state. We don't want to update this every time, only when there's actually a change in the score. Let's see if something fails. Font. Oh, we're not storing the font. That was nice of me. STL TTF font. Let's store it up here. Our font is STL TTF font, and this is a pointer, and this is the weird interface in Leaf. There we go. Right, let's see if we update the score when we get a point. We do. We have a 1 up there now. 2. So we actually have scoring now. Now, I'm not so convinced about the shape of it. We should maintain the ratio of it. And who knows how much time this costs us, because text is traditionally very costly. And because of the way I'm doing the rendering, and because of this copying back and forth, we have no idea how much time this takes. But again, we're on a desktop with infinite, essentially for our needs, infinite GPU uses. Alright, so we actually have a game where we have a score. Now, the one thing I want to do is I want to make sure the score has the correct ratio. And again, this re-rendering and uploading the text is actually really slow for a game. And so I don't know how much SDF text is used in STL games. because you can also, I can kind of notice, I don't know if you can notice the stream, it does feel like there's a small stutter when it updates that text. And I think it's doing re-rendering each time. I don't know how the library works. But what you would actually have is if you have your Atlas directly on the GPU, then you don't have to re-render. You have to recalculate the text positioning though, and that's also costly. Actual text positioning, like we were using Harf, Buzz, and Fuse, and actually calculating the positioning of the text characters is costly enough. But let's fail. Okay. Let's do the aspect ratio now. Let's buffer it slightly off so it has some space, 7/8, and then 8/8. And then what's the ratio of this thing? We want text score. This is a size, I think. Buffer. This has a size, which is a I'll just say this integer, y integer. I don't have a standard size structure in this part of the library. Size equals, and this is not the same values. They're not the same types. Width, velocity, STL Text.h. And so what do we have here? We should actually have text as a service. Actually, which way do I have to draw element? We're going to have to define draw text. And this is going to be, what did I say it? GL text texture, GL text texture. Text. And where do we want to draw it? We want to draw it where? We do a GL float 4. We'll use X, Y, Z, W. Actually, I don't want to draw it there. I want to say the size. So let's get rid of that. We don't need this. We don't need this. I want to make a helper function that actually does. I want to do a position, which is a GL float 2, and it's going to center it here. And I want to do a height or a width. Let's do a height. And this is just a normal float. I'm going to make it a GL float for consistency. Take all of this. We'll just do this one first of all. We want to draw text, and it needs to have the get opt text score, because this was optional. And where do we want to draw this? We want to draw it in the upper right hand corner. We want to say 0.89 it should center on, comma 0.94, and the height should be 1. And well, this is not going to center correctly. This is going to have to be right aligned. Alright, we're going to have to deal with right aligning here because this isn't quite correct. That should be good enough though, unless they have too high of a score. You know, let's just center it. that makes it easier for now. I don't have to worry about it. It's completely centered. So now the position becomes, well, what is the size of this? We have var source size equals text.size. And this is text.buffer. And so we have the height of the thing, so we need to know what the actual width is. The width equals, and it has width per height, so we're going to have lossy GL float. We need to convert this to a float. GL float source size dot x divided by lossy GL float source size dot y times the height, and that gives us the width. And so the x parameter is going to be position.x minus width divided by 2. Position.y, I think minus height divided by 2. And then it's width comma height. And if I did this correctly, well, we did it really large. I think I made the height too big. But it is centered. That's a good thing. It is centered up there. What did I say the size is? 1. With the height of 1, that's like, I think I meant 0.1. So there's a score at the top. And what I want to see is when we get to 10, does it remain centered? And you'd want to have some alignment things here. Without a UI, we're going to make this very, very simple. We walk behind the wormies, that's fine. I just want to get up to 10 so we can see where it's at. Alright, so now it's at 10, and you can see it still remains centered, I think. Yeah, you can see I'm going right on the side of it. Oh, no. Alright, so that's centered, and that's good enough. We have the text, we have it all centered. Oh, I think I accomplished quite a bit today. There's still some, ooh, it looks like there's still a blending issue here, but to hell with that. I don't care. What can I do else now? You know, I think that's about it. I think that's going to be good enough for today. I think we covered everything here. Well, let's make this other one do a text as well. Let's use draw text for the other one as well, because we want the other one directly centered. Don't know why. We want it to be fairly high. And we'll make that one centered as well. And this is title text, text title. So at least we have the correct ratio there. Oh, and we put it in the wrong spot. Well, we calculated wrong. I forgot 0,0 is the center. I always get that wrong. Alright, so now we have that text. It's a lot. It has the proportions. This font I found just has leaves on it. As I said, it has some leaves on it. So we have the score at the top. We have the Wormies text. Can't control the color of it. That's inside the thing right now, but that's okay. We have a basic game. And I'll have to think about what I want to continue doing with this game, because I'm accumulating a lot of things to fix in Leaf, and we have a lot of things we can't do in the game. We can start refactoring and starting adding other elements and stuff, adding screens and stuff, and we'll have to see how far we can get without needing to do too much refactoring in Leaf. Do I really want to do like the atlas for the text? We might have to, because it seems to be fairly slow. Oh no, I failed. Alright, but that's where we're at right now. Let me play once more to finish off the show. I won't be doing another stream today. We did the Evening Rust yesterday. Tomorrow, I'm uncertain if I do a TypeScript stream. I might not. I just don't know for sure. And there's some pop-up here, go away. Email about travel vacations. And I think I'm going to do more Leaf streams during the week. I'm going to try and do Rust in the evening, well, my evening, and Leaf sometimes during the day. And if I get to algorithms more, we'll do that. And I'll just finish the show with playing one more little game of Wormies, and I'll sign off on this. So we have a nice way to end it. These are the graphics. And again, as an overview, this is using my language, Leaf. It's the compiler. There's lots of stuff missing. The libraries we're using are STL and OpenGL. And we're doing this all basically from scratch. Otherwise, it's like the compiler, everything. And I've created 2 dudes of things to fix in the compiler. And it's a long road. We still have a long road ahead of us. But I think in this weekend, I've actually made more progress than I suspected I would. And if I get further, I'll actually do algorithms. Well, maybe we should implement the CPU guy next. That'd be a good addition. Put a CPU player in here, which also tries to eat the dots. And the one with more points wins. But of course, then the shorter guy is just going to not eat anything. And this will help. This will complement the work I'm doing on Evening Rust, where we have algorithms like this in the show. Yeah, where we have algorithms in the show. Alright, so unless there's no more questions, I'm just going to play this game to the end until I die and see how well I do. It's been so long since I played such a game. And if something goes wrong, I honestly have nobody to blame myself. I've written the driver, I've written the compiler, I'm the one playing the game, we've written the graphics. There's absolutely nothing in this that I haven't actually written. So when I die, it's my fault. I probably should have increased the length by more than 2 at a time. I could probably play a long time here. Maybe I shouldn't. Well, let's take some risks. So I'm hoping you're enjoying the show. And we'll end here. All the code's on GitHub. Well, the compiler's on Launchpad because I actually prefer Bazaar, but I'm using Git for some of the code because people like Git. Uh-oh. Did I screw myself? No. We can go through the top of the screen, so this is okay. Now we have to wait. We queue up actions so we can actually do this correctly, what I'm doing right now, which means you could actually play forever. You should get a perfect score. But it's going to take longer and longer to get these things because we don't exclude them from the spots. Well, on second thought, I might not actually play this to the end because I realize I'm doing better than I expected. Up until right now. Haha! Whoa, that was cutting it close. Okay, maybe I am long enough now that if I just play like an idiot... No, no, Okay, so I failed. Alright, thanks for watching. We've been doing well here. We're going to keep adding more stuff. We have many things we can add to this. Hopefully not too much that we have to keep doing Leaf, because Leaf is going to be slower progress than the actual game. We can add sound, we can add game controllers and stuff like that. That might be a 1-1 game controllers, because I suck on keyboards. And I thank you very much for watching, and I'll see you potentially next weekend. But the week after that, I don't know how much I'll do. Thank you very much for watching. I hope you enjoyed the show.